Hello everyone, this is Professor Mahesh Pardeshi from Parvatibai Genba Mose College of Engineering, Wagholi, Pune. Today we are discussing the problem based on our next topic, that is welded connection. Okay, so let us read the problem. Determine the length of 10 mm size fillet weld. What we have to find? We have to find the length of the weld. Okay, what we have to find? We have to find the length of the weld required to connect the two plates 120 mm by 10 mm. Here you can see, here this is the first plate having the width is equal to 120 mm and the thickness of the plate is 10 mm. Okay, and 180 by 10 mm. This is another plate which we have to join. This is plate number 2 having the width 180 mm and thickness is equal to 10 mm. Okay, the load to be carried is 300 kilonewton. Okay, here the load is given. Here you can write P is equal to 300 kilonewton, or which is equal to 300 into 10 to the power 3 newtons. Okay, the load is given, that is 300 kilonewton. Consider the grade of the plate is Fe410. Here the grade of plate is given, that is Fe410. Grade of the plate is Fe410. From that we can find Fu is equal to 410 Newton per mm square. This is nothing but the ultimate stress of the plate. Okay, here the grade of plate is Fe410, therefore ultimate stress is equal to 410 Newton per mm square. Now what is given? And welds are to be made at the workshop. Here what is given? Welding is made at the workshop. Here depending on this value of the gamma mw, value of gamma mw is depend on this factor. Okay, this is equal to gamma mw is equal to 1.25 in case of the shop weld. Okay, here the welding is done at workshop, that means shop welds. In that case value of the gamma mw is equal to 1.25, and if field weld is given, field weld is there, means if welding is done on site, in that case the value of gamma mw is 1.50. Here the value of gamma mw is 1.50. Okay, now here this is all about the given data. Okay, figure is given here. Show this figure carefully, and now we are starting with our problem. Okay, what we have to find? We have to find the length of the fillet weld required. First of all, we have to find throat thickness. What we have to find? Throat thickness. Throat thickness is denoted by small t. Throat thickness is denoted by small t and its value is K into S. Formula is given in the IS code, IS 800, page number 78. This formula is given. Throat thickness is equal to K into S. Okay, now what is meant by this K? K is nothing but the constant and its value is depending upon the angle between fusion faces. Okay, this K is nothing but the constant. Its value is constant and it is depending upon the angle between fusion faces. In most of the cases, angle between the fusion faces means angle between the welding. Okay, here we have to, suppose we have to provide the welding here, here and here. Okay, in most of the cases angle between these two faces is 90 degree. Okay, and for that 90 degree angle the value of K is 0.7. Value of K is 0.7. It is given on page number 78, table number 22. Okay, this value is given on page number 78, table number 22. In most of the cases angle between the fusion faces is 90 degree, and for that 90 degree value the value of K is 0.7. Okay, put the value here, 0.7 into S. S is nothing but the size of the weld. S is nothing but the size of the weld. It is given in the problem itself. It is given in the problem itself. Here you can see 10 mm size fillet weld is given. That's why the size of the weld is 10 mm. So multiply by 10. So throat thickness is equal to 7 mm. Throat thickness is equal to 7 mm. Okay, throat thickness. Now second point, we have to find the design strength of the weld. What we have to find? Design strength. What we have to find? Design strength. This design strength is given on page number 79. Okay, this design strength is given in page number 79. What we have to find? FWD. What we have to find? Design strength in welding. Weld FWD is equal to FWN divided by gamma MW. This gamma MW. Okay, FWD is equal to FWN divided by gamma MW, and this FWN is equal to FU divided by root 3 divided by gamma MW. Gamma MW. This value is given, this formula is given on page number 79. See the IS code. Here on page number 79, formula is given here. Okay, formula is given here. Check this formula, page number 79. Okay. Now put the values. FU is 410 divided by root 3 into divide by value of gamma MW. Here in our case shop weld is used. Okay, shop weld is used. That's why the value of gamma W is 1.25. 1.25. Okay, solve this. Calculate this value. All of you calculate this value. $189.37. Its value is 189.37 Newton per mm square. Okay, 189.37 Newton per mm square. Okay, what is this value? It is a design strength in weld. It is nothing but the design strength in weld. Now we have to find strength of the weld in 1 mm length. What we have to find? Strength of the weld per mm length. Strength of the weld per mm. Strength of weld per mm. Okay. So we have to find the strength of weld for a single mm length. Okay. In that case, we have to multiply this design strength with the throat thickness. Okay. Because that much depth of the weld is required or provided at that section. Here the throat thickness is 7 mm. Okay. That's why what is the meaning of this 7 mm? That 7 mm depth of the weld is taking the load. Okay, that 7 mm depth of the weld is taking the load. That's why while calculating the strength of the weld per mm, we have to multiply this design strength by the throat thickness. Okay, it is 189.37 into 7. Calculate this value. Got it? Got this point? Strength of the weld per mm means single length of the weld is taking how much load. Okay, that we will get from this design strength of the weld multiply by throat thickness, because that much depth of the weld is there to take the load. Okay, that much depth of the weld is there to take the load. That's why we have to multiply by this throat thickness. Okay, calculate this value. Calculate this value. 1325. It's 1325.29 Newton per mm. Newton per mm. Why it is Newton per mm? Because we are multiplying by throat thickness. Its unit is mm. Okay, that's why Newton per mm square into mm get cancelled and unit remains Newton per mm. Okay, because it's a strength per mm length na. It is a strength per mm length, that is nothing but the load per mm. means 1 mm welding is taking the load of 1325 newtons, nearly about, okay. 1 mm length of the weld is taking the load of 1325 newtons. 1325 newtons. Now what we have to find? We have to find the length. What we have to find? We have to find the length of the weld required to take the load of 300 kilonewton. What we have to find? We have to find the length of the weld required to take the load of 300 kilonewton, okay. 300 kilonewton. From this we will get easily, okay. Length of the weld required, length of weld required is equal to simply how much load we have to take? 300 kilonewton, and per mm strength of the weld is 1325. Just divide, okay. Therefore load divide by, or you can directly put the values, okay. You can directly put the values. Here load is given 300 into 10 to the power 3, unit is newtons, divide by 1325.29 newton per mm. So newton gets cancelled and unit remains mm, okay. Calculate this value. What will get? 226.31 mm, okay. So we can round up this value. Therefore this length is equal to 230 mm, okay. Length of the weld required is 230 mm, okay. This value we have to find. Here you can see, determine the length of the 10 mm size fillet weld required, okay. And this is equal to, L is equal to 230 mm, okay. The problem is over, but main thing is remaining, okay. What is the main thing? How to provide this length 230 mm here, okay. How to provide this length 230 mm here? For that we are having two options. First option is, we will provide the length of the weld along these two sides only these two sides, okay. We have to provide the length along these two sides only. Why it is so? Because very important criteria in providing this welding length is, we have to coincide the CG of the welding to the CG of the section, okay. This is a section along which we have to provide the welding. So we have to match CG of the welding to the CG of this plate or CG of this section, given section, okay. First of all we have to find the CG of the section. Here the CG of the section is at midpoint because it is a plate section, okay. CG is here, okay. So we have to provide the welding in such a way that the CG of the welding should match with the CG of the plate, okay. Here how it is possible, or how we have to make this? To make this, we have to provide the welding length equally along both the sides. We have to provide the equal length along both the sides. This is the first case, okay. Here I can write first case. In the first case, here first case, L1 is equal to L2 is equal to 230 divided by 2, which is equal to 115. This is the first case, okay. Equally we have to provide equally along both the sides. Here L1 is equal to 115, here L2 is equal to 115. This is case 1. Now what is happen in case 2? Here case 2. In case 2, first of all we have to provide the welding along this side. First of all we have to provide welding along this side. Here you can see, okay. Here the CG is here only, okay, CG is here only. So if we provide the welding along this side, we can complete our some part of the welding length, okay. See here in first part, start with the L3. This second case, start with the L3. How much length is available there, first that we have to check, okay. Here the length of the welding available is 120 mm, because here you can see the width of the plate is 120 mm, width of the plate is 120 mm, so we can provide the welding length 120 mm, okay. So L3 is equal to 120 mm, okay, L3 is equal to 120 mm, and the remaining length we have to provide along these two parts equally to match the CG with the CG of the plate, okay. This is our main criteria, CG of the welding should match with the CG of the section. For that, the balanced welding length or remaining welding length we have to provide along these two sides equally. Therefore, balanced length L1 is equal to L2 is equal to 230 minus 120 divided by 2, okay. This is overall length, 120 already provided, that is nothing but the balanced length, divide by 2 because both the sides equal length, okay. This will gives you 55 mm, okay. This will equal to 55 mm. So in second case we have to provide 120 mm length along this face and 55 along this and 55 along this. This is the main point, how to provide the welding length in a section, okay. This is very important point, this we have to find, but actually how to implement it, this is also matters, okay. So we can implement it by using these two cases, okay. We can implement it by using these two cases. Hope you understand this problem very well. To understand it is in deep, you have to solve by own 1-2 problems, okay. Solve by your own and suggest me any questions, any doubts. If you are having any doubts, please comment me. I will explain in the next lecture, okay. Thank you.